Hello! Second period, seventh period, and eighth period algebra students. Mr. Lawrence here, and I'm going to go over some of the review questions on the test. And if I think of a couple things, I will pass those along with you. First of all, I've got problem number 4 here. We have 3x over 8 plus x over 5, and I'm rewriting it so that I can show the work better. And I know I don't like this problem because there's fractions involved, so I'm going to multiply by the least common multiple. Like some of you want to multiply by 8. The problem is multiplying by 8 will cancel these fractions, but it won't cancel with the 5, so 8's not going to work. All right, now some of you say, hey, I want to multiply by 5 then. Well, 5 will work on this fraction, but it won't work on this one. It won't cancel out the 8. They don't cancel. So what number am I going to use to multiply by to get rid of both fractions? Well, I'm going to use 40. It's the least common multiple of 8 and 5. So I'm going to multiply by 40 over 1 here and by 40 over 1 here. And as Holly Krieger would say, I got to multiply by 40 on the right-hand side. I heard that today in class, Holly. Good job. All right, so now when I do this, I'm going to get 40 on the right-hand side. Now please show the work. Don't just cancel it. Turn it into an 8. 8 times x is 8x. All right, I got a plus sign out there. 8's going to go into 40 5 times. Now this is multiplication, right? It's not addition. I don't get 8x here. I get 15x. So 8x and 15x combining like terms gets me 23x, and that's going to be 40. All right, I'll divide by 23, I'll divide by 23, and then x will equal 1 and 17/23. Should be pretty simple enough by now. The solution set for that will be 1 and 17/23. All right, there we go. Okay, on a number line, of course, I would have, I'll probably show 1, I'll show 2, 1 and 17/23. It's going to be closer to 2 than it is to 1. And then I need a closed point right there because it is equal to. Oh, excuse me. All right, moving right along like 2. All right, sorry, going into Kermit and Fozzie mode there. All right, so I've got problem number 5. Now I'm going to go ahead and distribute here. And when I do, I'm going to get negative 3x minus 15. And then I'll distribute on the other side, and when I do, I will get 3x minus 3. All right, now I don't like it because there are x's on both sides. I'm going to get rid of this negative 3x. When I do that, I'm going to get a negative 15 equal to a 9x minus 3. I'll add 3 to both sides. I'll get a negative 12 is equal to 9x. I'll divide by 9. I will simplify, dividing both of them by 3, right? Because negative 12 can be thought of negative 4 times 3, and 9 is 3 times 3. And so look, those are going to cancel. So x is going to equal negative 4/3, and I'll go mixed number and make it negative 1 and 1/3. My solution set will be negative 1 and 1/3. And then on a number line, I'll show negative 2, show negative 1, negative 1 and 1/3, and I'll have a closed point right there. All right, let's see here. Number 9. Oh, inequalities. Got to be careful with inequalities. Got to remember that with an inequality, if you multiply or divide both sides by a negative, did you hear that? If you multiply or divide both sides by a negative, the inequality is going to change direction. So I'm going to multiply this side by 9 over 1 and this side by a plain old 9. And you know what? I think I'm just going to use a 9. Yeah, I'm just going to do that. The 9s will cancel. I'll get a negative 7x is less than 90. And then I'll divide by negative 7. And then warning bells should be going off. Whoop, whoop, whoop. I'm dividing by a negative 7. X is going to become greater than, let's see, 7 is going to go into 90. Let's see, 1, 7, 24, 14. Let's see, 14 and 6 sevenths, but it was divided by -7, so it would be a negative. All right, now when I go to do my solution set, it's going to look a little more complex. I'm going to do the brace, and then x is any real number such that x is greater than -14 and 6/7. All right, on a number line, shoot, I've got to show this -14 and 6/7. I'll show a -15, and then over here I'll show a -14. I'll do an open point because it's not equal to. Blank is greater than -14 and 6/7. Well, numbers greater than -14 and 6/7 would be to the right. So like if I chose 5, so I will shade to the right. Okay, very good. Now number 10, let me use the bigger eraser here. All right. If you need to see that, you can always rewind that part of the video, right? Not a big deal. All right, number 10. 10 is 12 minus x over 6 is greater than x plus 7 over 4. Well, there's fractions on both sides. They're kind of screwing me up. So I'm going to multiply. I'm going to multiply by the least common multiple. What is the smallest number that both 6 and 4 divides into? 12. So I'm going to multiply by 12 over 1 here, and I'm going to multiply by 12 over 1 here. I'll pay close attention to this one. 6 is going to go into 12 2 times, so a 2 is left over. So right now I have 2 times the quantity of 12 minus x, and I will distribute. In other problems you've seen there's nothing left to distribute except a positive 1, which is a waste of time. But in this one there's a 2 out front. It's 2 times the quantity, so I have to distribute. Okay. Over here I'm going to do 4 goes into 12 3 times. I will distribute the 3. And I will get x plus 7 times 3. And so I'll get 3x plus 21. All right, I don't like that there are x's on both sides, so I'm going to add 2x to both sides, giving me 24 is greater than 5x plus 21. I'll subtract 21 from both sides, and I'll get 3 is greater than 5x. Dividing by 5 will get me that 3/5 is greater than x. Or I could say x is less than 3/5. Notice how I had to flip the inequality if I'm going to change both sides. All right, my solution set would be x is any real number such that x is less than 3/5. Close my brace. On a graph, on a number line, I've got to show 3/5. I'll show 1. I'll show 0. It will be an open point because it's not equal to. Excuse me. And then I need a number that is less than 3/5. Well, how about 0? So I'll shade toward the direction of 0. There you go. There's number 10. All right, hold on 1 second. My throat is getting a little scratchy. Numbers 12 and 13 aren't really more difficult. They're just a little bit longer. So for this one here, I'm going to add 6 to both sides, right? And I'm going to get 2x. Well, that's not an x. What the heck is that? All right. 2x is greater than 16. Divide by 2, divide by 2. X is greater than 8. Or, I'll add, here, let me do that in a different color. I'll add 6 to both sides, and I'll get 2x is less than 10. Put my or in there, divide by 2, divide by 2. So x is going to be less than 5. My solution is this. There's my mathematical sentence. It's got an or in it, you know, like a conjunction. Conjunction, junction, what's your function? My solution set would be x is any real number such that x is less than 5 or x is greater than 8. And on a number line, I've got to show the 5, I've got to show the 8. They're both going to have open points. Shoop, shoop. I need numbers that are less than 5. Well, I know 4 is less than 5. That would be to the left of 5, right? And I need numbers greater than 8. Well, that would be to the right of 8. All right, there you go. Problem number 13. I think I'm going to rewrite this one, give myself just a little bit more room. Remember, I didn't have to do it in a little while, but whenever I'm dealing with inequalities, I'm always watching for when I have to divide or multiply by a negative. Remember, the inequality is going to change directions. So I'm going to subtract 6, I'll get negative 3x is less than or equal to 6. I'll divide by negative 3, divide by negative 3, and x is going to be greater than or equal to negative 2. And, okay, subtract 6 from both sides. I will get negative 3x is greater than or equal to negative 6. Divide by negative 3, divide by negative 3. And then x is going to be less than or equal to positive 2. Notice in both cases I divided by a negative. On both sides, the inequality changes direction. All right, there's my sentence. If I want to circle it, I can. Set notation. X is any real number such that, and you can certainly rewrite this. I prefer to do it this way. Negative 2 is less than or equal to x. Isn't that true? If x is greater than or equal to negative 2, isn't negative 2 less than or equal to x? And then since x is less than or equal to 2, I'll just write it like this. You can never do that with an or problem. Never write it as one sentence. I'm writing as one because it's an and. I like to do it that way, but you don't have to. All right, I got a number line here. I've got to show negative 2. I've got to show positive 2. And then I'm going to put closed points because they're equal. Closed points because they're equal. And I've got negative 2 is less than or equal to some number, which is also less than or equal to 2. Well, how about 0? 0 makes that true, and 0 is in the middle, so I'm going to shade in the middle like that. All right, moving right along. Okay, the difference subtraction of 7 and twice a number. Hey, if I said to you the difference of 5 and 3, wouldn't you write 5 minus 3? If I said to you the difference of 20 and 10, wouldn't you write 20 minus 10? All right, if I said to you the difference of 3 and 5, you would write 3 minus 5. So you don't always put the bigger number first, okay? You take them in the order that they come. So when I say the difference of 7 and twice a number, that's going to be 7 minus 2n. How do I know that? Because the 7 comes first, and twice a number comes second, is 31. So now I'm just going to solve. I'm going to subtract 7 from both sides. I'll get negative 2n equals 24. Divide by negative 2, divide by negative 2, and it's going to equal negative 12. There you go. If we did a solution set on it, it would look like that. Okay, I'm not going to make you graph that one on a number line. All right, number 17, a little bit longer. The quotient means division. I'm going to need a division bar, or fraction bar, excuse me, of the quantity of 10 less than a number tripled and 4. That's my quantity. So I need 10 less than a number tripled. Okay, and 4. This is my, oops, excuse me. 10 less than the number tripled. I made a mistake there on my quantity. I should have put the quantity right there. Okay, this 4, because it's following the and, is my denominator. Because of the quotient, I need a denominator. It's the number after the and. So 10 less than a number tripled. Well, that's going to be 3n minus 10. If you want to put parentheses, you can, but they're not necessary. Is greater than twice the number. Oh, twice the number, 2 times n. It's greater than 2. It's greater than 2n. All right, I don't like this because it's got a fraction, so I'm going to multiply by 4 here. Going to multiply by 4 here. And so 3n minus 10 is greater than 8n. I don't like having variables on both sides. I'm going to subtract 3n from both sides. Negative 10 is going to be greater than 5n. Divide by 5. Divide by 5. Will the inequality flip here? Hopefully you're saying no, because I did not divide by a negative. I divided into a negative, but not by a negative. And so there is my solution. So n can be any number less than negative 2. Okay, as a solution set, I could say n is any real number such that n is less than negative 2. If I was going to graph that on a number line, of course I would show negative 2. If you want to show negative 1 and negative 3, you go right ahead. And so I'll have an open point, and the numbers that are less than negative 2, like say negative 5, are to the left of negative 2. There you go. A couple things I just want to point out really quick. Remember that when we say 7 less than a number, that means n minus 7. It does not mean 7 is less than a number. Notice I said is on this one. You got to have the word is in there. This one doesn't have an is. So this would not be the correct one. This is right as 7 is less than a number. This just says 7 less than a number. The is makes a big difference. Another thing I want to point out is that when you have 5 minus x over 3 less than, say, 2, some of you like to multiply first. I would subtract 5 first, but if you're going to multiply first, I think Julia Lakac might want to do that. I'm not sure. I was thinking she did that. You have to remember to multiply this by 3 as well. So you're going to get 15 minus the 3's will cancel, x less than 6. Subtracting 15 from both sides, I will get negative x is less than negative 9. Divide by negative 1. Divide by negative 1. X will be greater than 9. Okay, the inequality flipped because I divided by a negative. Okay, that's it for the video. We'll review in class tomorrow. Have a good night, everybody.